years.
Well, hello everybody. Welcome to Gregg's Vintage Workshop, where I'm restoring history one piece at a time. Today we'll be doing part 2 of the Philco 7070 signal generator, and we will be fixing a mistake I made in part 1. In part 1, I tested the power transformer, I replaced the electrolytics, and I restuffed and replaced the wax caps. I did make a mistake with those caps, and that will be the first part of part 2 that you'll see. Also in part 2, I will be testing and replacing resistors and testing the remaining coils and reluctors. And then towards the end of the video, I actually get into some of the refinishing of the case as far as sanding and painting. So without further ado, let's get started. We got a lot of work to do. So in part 1, we actually replaced this cap and this cap. But I have to tell you that I screwed up. I was so intent on changing those out that I didn't bother to even look at the rating on this particular cap. I was going back through the schematic after I finished that video and realized that this cap is not a 0.05, it's a 0.02. And if I get in there closer, you'll see that. I mean, you'll see it now because once I realized it was a 0.02 and not a 0.05, I went back and got the old one and unstuffed it and put a new 0.022 in there, restuffed it, put it back on there correctly. So that's why we always look at the schematic. So we always check our work, and I caught that mistake. So the other thing, all those resistors. I went back and I started checking the resistors, and lo and behold, I had R109, which is supposed to be a 680 ohm resistor, was coming in at 1047. So I knew I had to change it. Well, in the process of changing it, I broke one of the other resistors because it was so tight in there. Of course, you realize the resistors were much bigger than these. So I had to change that one. So when I went that far, I was like, you know what, I'm just changing all these. So basically, I changed R109, which was a 680, R111, which was a 68K, R112, which was a 220. And I'm looking at my cheat sheet where I recorded everything. And so I replaced those and moved on with life. So while I was checking resistors, and this one, by the way, is good. There's no reason to change that. So while I was checking resistors, I was like, oh, you know what? I didn't check the resistors in that attenuator box. So since that time, I changed these resistors as well. One of those was testing out a tolerance on the bottom. It was a 4700 and it was open. So since I had to get to that anyway, I had to tear all of this apart. So while I had it apart, I was like, you know what? Again, I'm just changing them all. So I changed all those. Here's a couple of photos of while I had it out. I cleaned it all up. Took a photos of it before and then some photos after. So the other thing that I did while I had this apart was, remember that attenuator switch. Remember, maybe it wasn't the attenuator. Let's see what it was. I don't have the cover. Oh, that reminds me of the other thing that I also did. I took the cover off because I was afraid I was going to get it scratched. So that's the cover. Now I did go on eBay today and order some hammer paint that I'm hoping is going to come close to this, but we'll see. So the multiplier is this switch. And if you remember when I was originally showing it to you guys, I said this one was really stiff to turn. Well, this was it. And it was really stiff to turn. So what I did, well, I had to take it out in order to get this all off of here. This terminal solders here. And this one goes to that cap in this resistor. And of course this one goes right here. It goes up through a hole in there. So first I freed it up with some WD-40. And then I sprayed deoxit through it, in it, all around it. And what we're getting ready to do right now is test it. So I've got you up on my meter up top there, and we're going to test this out and make sure that it is working good. So we'll just clip this right here, and I'm going to hold, hopefully I'll hold you in the screen. I'm clip that one right there. I'm going to hold this one right here, and I've got you up top at the meter there. So let me turn this all the way, one way or the other. Let's go this way. Try and get my hand where you can see my hand too. I'm sorry. Alright, so as you can see, we're about a 1. Alright, so I'm going to start turning it slowly. Alright, wait a second. I'm losing my connection here. Let me get a better connection. Let's do this again. Alright, so I'm going to start turning it slowly. And as we can rotate around here, you can see it smoothly climbing. If I had this on an analog meter, it would be definitely smoother than it is on this digital, but as you can see, it's actually working quite well, all the way up to about 1126 ohms, and then back down again. So, and I'm turning it quickly now, obviously. So that's that. That tested nice. It works good now. It was all seized up. So now we can get this back installed inside of here. So let me just kind of feed this in here. Maybe. If we can get it in there. Easy for me to say, right? Let's see here. I might have to shoot a little silicone spray on that to get that in there. There it goes. There it goes. I just had to get the twist just right on it. And I get my needle nose pliers here so we can feed this back up where it needs to go. And a little bit more. There we go. And then it went in this one right here. In there. There we go. Okay, so that went in there like that. And this fit down like that. This terminal goes down here and solders down here. This goes over to this terminal. This goes over to this terminal. So let me get that stuff soldered all up and we will come back. Okay, so I got that stuff soldered back up. One thing I did want to show you is I think you can see it through my magnifier. That's what I'm trying to do. When I did the switch, one of the things I noticed was, if I can get my face where I can see too, this terminal right here, this rivet was a little loose. Not extremely loose, but a little loose that this could actually pivot slightly. It was making good contact with the actual switch, but it was pivoting slightly. So I just mixed up a little epoxy and just dropped a drop on there. Cleaned this all up good, and I dropped a drop on there. That'll keep that from ever moving. So that should be good to go. And then over here, I got that soldered back. If you can see that, hopefully through the magnifier. All right, so that's soldered back, we're soldered back in there. This area should be complete. We can go ahead, I think, and button this can back up. So even though I did it once before, I think that we're good to go now. I'm going to go ahead and button that back up. So let me do that. All right, let's put our lid on here. Try to put the lid on there. There we go. One thing to show you, I use my little pill bottles. My wife says I hoard everything. A lot of the stuff I put in little pill bottles. That way it doesn't get lost. And the things that I took off, some of the things I took off are in this pill bottle. Like my star washers. I'll find the last one right there in my hand. Alright, so put that one on there. And the nuts. And the nuts. Put the rest back in there. If you saw, I had a little bitty Allen wrench in there. I did that because I didn't want to have to find it again. I actually took it off of one of these, because it wouldn't fit. I had to use that to take the actual dial pointer off. Very small Allen head in that. Finish tightening these up. All right, this section's complete. Now, the other thing we didn't do the other day when we were working on this was test the modulator coil. Get the schematic out, turn it right side up, get my pointer, and this is the T100 modulator coil right here. Make sure I'm holding you where I can see and you can see. Yeah, it's the modulator coil here. So I did already test this, but I'm going to test it again for you guys. Okay. Now we're set up. So let's go ahead and check these. So we're going to be checking the blue wire to the red wire on this modulator coil. It's a secondary. It should be reading about 1770 according to the print. So let's see what we got. That's about 1740. All right. So the primary, well, let's separate that out because that's the full secondary, but this actually has a center tap on it. So if we go to center tap, which is the brown, we can go blue to brown, and we can go red to brown. So let's go blue to brown. The blue's on. We're on the blue, and we're going to go to brown. Oh, it's right here. It's coming through the chassis right next to the green wire. So there's our brown wire. And for a blue to brown, we got 810. And so now we go brown to red. Alright, so there's the red. We're going to go to brown. And we are 915. So pretty darn close when you add those two up to our 1740. So alright, good. So that's good. Okay, So we got the main section of the Philco 7070 recapped. What am I holding in my hands here? This is actually the guts from the power supply box, the little box that was inside of the housing that the inside cord plugs into. This is the cord that was from that other section from the power transformer. The box itself was spot welded to the inside of that case, so I couldn't remove it, so I removed the guts from it. It actually used two of the screws that hold the handle onto the case. So anyway, I had these two screws and these two screws held it into that case. So it consists of two inductors here and two inductors here, two capacitors here, two capacitors here. If we look at the schematic, something to point it out to you with, we have a 100 microhenry inductor here and a 1.5 microhenry inductor here, and the same over here and here. And then we have the 0.05 capacitors here and here, and then some 100 PF capacitors here. So these are the 100 PFs, and they are mica capacitors. I looked them up not only on the sheet, but I looked them up on my color coding chart just to make sure, and they're the 100. And because they're micas, I'm not going to mess with them. These are the 05s, so I've got to get the 05s. I'll probably restuff them. I thought about not doing it, but I restuffed the other ones on the thing, so I might as well restuff these as well. And we're going to check these inductors with my little cheap Chinese meter here. Let's see if we can get it hooked up to one and then the other. So we got this one going to go here, and this one's going to go there. Maybe it will. And we shall see what we get here. Maybe if I got a good connection. And we are getting 0.10 millihenry, which 0.10 millihenry is the equivalent to 100 microhenries. So that one's okay. That matches the print. See if we can get the other one now. So for the other one, we got to go right here. If I can get onto it, let me pick it up, see if I can get on there. There we go, I think. And right, let's see what we get. Make sure you're still on camera. Oh, 9 millihenries. Right at the 0.10. So again, both are good. Now, these other ones, the smaller ones, are going to be the ones that are the 1.5 microhenries. That's going to be really fine when it comes down to a millihenry, so it may not read it. We're going to see what it does. It's just showing it as a resistor, and it's showing it at 0.46 ohms. We know it's not open, so I'm going to assume, because it's so fine, that this cheap Chinese meter won't read it. Let's try this one. See if we can get it. 0.44 ohms, so that's pretty darn close. The other one was 0.49, this one's 0.44, so they're not open. They look really good. I'm going to use them as is. So really, all I need to do is restuff 2 0.5 caps. These are the power wires. I need to get those off and get another cord ready. Figure out a way I can fuse this inside that box if I got room to put a fuse in there. And I'll come back. Alright, so here we go. Those are the 2 new caps. I did the coil method on them so I wouldn't have to heat the legs up too much. So they're on there. Spread some deoxit down in this outlet right here a little bit and worked a little tiny file in there. So this piece is done. The next thing will be to put this in the box. But currently I'm working on the actual box. As far as I sanded it all off and I repainted it with the hammer paint. Unfortunately, the hammer paint didn't turn out all that great. It didn't hammer. And the color is too light, unfortunately. But it is what it is. It'll work. It'll be good enough for me. Anyway, all I got left to do to this is solder the new power cord and figure out a fuse for the box. See if I've got room in that box. But I can't do anything with the box right now because it is in the process of drying. In fact, let me take you over there and show it to you. Alright, so there is the box. And as you can see, or you probably can't see, it doesn't look very hammer-like. I mean, the shine's okay, but it doesn't look very hammered. And then on this side, I had a splatter that shot out right here and right here when I was spraying the last coat. Of course, that's the way it always works. But it is what it is. It's better than it was. I still got to paint the handle, but that be the box. So I guess we'll go ahead and end this video here because we're probably starting to run kind of long. If you're new to Gregg's Vintage Workshop, you haven't hit your subscribe button previously, please hit and subscribe. I'd love to have you. If you look in your upper left-hand corner of the video, there'll be one that I recommend that you take a look at. So from Gregg at Gregg's Vintage Workshop, thank you for watching. Stay safe and stay healthy.